Okay, this is section 1.1, part 2, Math 105, and we're going to talk about sets next. So a set is basically just a collection of objects, okay, any objects, and these objects are called elements, okay, so an element is part of the set, okay. So usually we use capital letters for a set like S, okay. So if we say that, and we use lowercase for elements of sets. So we say A is an element of S. We could write it like this. A is an element of the set S. You can see that. Okay. So that means A is an element of the set S. Okay. Sometimes we use Z for integers, so you'll see Z there. Okay. Capital Z. Don't worry about that, but we can say -3 is an element of Z. Okay, I use a little cross for the Z. So we could say -3 is an element of the set of integers. But we could say, 2/3 is not an element of the set Z. So I put the little E there with a cross through it. Okay, so that little trident E means it's an element of. You put a little slash through it, means it's not an element of. Okay. So we can list elements in braces using, we call that roster form. So like set A here is all the positive integers from 1. You can see set A here is 1, 2, 3, 4, 5, 6 on the bottom there. Okay. Okay. Now set builder notation is another way to describe a set. And generally use that if we can't list the elements. So we have this notation here. There's the set A equals, and we always use these braces for sets, whether we list the elements or we use set builder. But we're always going to start with X with a bar. And that literally means the set of all X such that. Okay, that's what the X bar means. And then the rest says, what do we do? What is X? Well, X is an integer, and X is between 0 and 7. This is called a compound inequality, where this is your smaller element, this is your larger element, and means X is between those. So we're saying X is between 0 and 7, less than's there, and it has to be an integer. So we're not going to include 0 because we don't have an equal to there. We're not going to include 7, but we're going to use just the integers between 0 and 7. So that's going to be 1, 2, 3, 4, 5, 6. So this is a way to describe that set from the previous page, 1, 2, 3, 4, 5, 6, using set builder notation. Okay. And literally that means A is the set of all X such that X is an integer and 0 is less than X, which is less than 7. Okay. All right. Okay, we talk about union of two sets. We're including all of the elements that are in either set or in both. So we're basically putting everything together. So if it's in one set or the other, we include it. If it's in both sets, we include it. Okay, so that's union. Okay, think of a union as like a collection of elements. We get them from both sets. So I'm in a union for lecturers union. So it's all of the lecturers are in the union. Okay. Intersection would be just the ones that are in both sets. Okay, all elements that are in both S and T. Okay. Now let's look at a few sets here. We have set S, which is 1, 2, 3, 4, 5. Set T, which is 4, 5, 6, 7, and set V, which is 6, 7, 8. Okay. So this notation is a little messed up, but we're taking S or T, which is S union T, which means we're going to take all the elements in S and all the elements of T and just throw them all together. So we do that, we get 1, 2, 3, 4, 5, 6, 7. Okay. S and T, or S intersection T, we're looking for elements common to both. So it's just the ones where we overlap. So it's 4 and 5 that are in both of these sets, not 1, 2, 3, or 6 or 7. Okay. So that'd be S and T or S intersect T. And then let's look at S intersect V. Okay, we want to see where those two sets overlap, and there is no overlap. There's no elements that are in both sets. So we say S and V, or S intersect V, is just empty set, which we could write with just this little O with a slash through it, or we could write it like this. Just put your set braces with nothing in there. Okay, so there's another way to do that. Okay, a lot of times we can't just list the elements in a set because maybe we're talking about a whole continuum of elements. So we define intervals, and that means we're going between two numbers and we're including everything between two numbers. So we call that intervals. And we're talking about kind of like section of the number line, right? So, or line segments. Okay, so we start with A less than B, so A is going to be left of B, and we talk about an open interval. Open interval means we don't include A and B, and we would write it using interval notation as this. This is the start point, A, and this is the end point, B. Okay, so that's an open interval. Okay, I'll use blue instead. Closed interval means we include the endpoints. So closed interval includes the endpoints, and that we'd write with AB with brackets. So don't be confused by order pairs here, because these are not order pairs. This is just start point, end point. Okay. We can also write these using set builders. So the open interval would be the set of all x such that A is less than x, which is less than B. Okay. And the other one, the closed interval going from A to B, including A and B, would be the set of all x such that A, this would be less than or equal to. So let me rewrite that. Okay. This would be, let me rewrite that. So the set of all x such that A is less than or equal to x is less than or equal to B. Okay, so that's what that set should look like, not this one. Okay. This is what the open interval would look like if we graphed it. See, we have circles there for A and B because we're not including those open circles, and we have everything between A and B. It's not just integers, but it's all the real numbers between A and B. Okay. The closed interval, we're going to have those points filled in at A and B. Okay. Include those endpoints. So here's how we define different types of intervals. The open interval is going to be the set of all x, such as A is less than x, which is less than B, and this is what it looks like graphically. So we're defining these sets three ways: interval notation, set builder, and graphing. Just three different ways of saying the same thing. Closed interval, we're going to use brackets, and we're going to have the set of all x such that A is less than or equal to x, which is less than or equal to B, and that would be closed endpoints on the graph. Okay. Here's a mixed interval where we include A, but we don't include B. So we're going to have the less than or equal to on the A, but not on the B. And then you see we have the red dot filled in on the A, but not on the B. And then this is the opposite, where we have B included, but not A. So we're going to have the less than or equal to for the B, and then we have B filled in. Okay. And then these are kind of open-ended intervals where we go from A to infinity, but we don't include A. So this would be, we could write this really as x is greater than A, and really that makes a little more sense. But x is greater than A, we're not going to include A, and we go to the right forever. Okay. This would be x is greater or equal to A. We rewrite this, backwards, and then we're going to the right from A filled in. Okay. These would be going from negative infinity to some number, and here we're not including B, so this would be x is less than B, and we can see the graph there. There should be an arrow going that way. It keeps going forever to the left, not including the B. When we put a bracket on the B, now we're saying x is less than or equal to B, and so we're going to the left. Okay. And then if we wanted to find the full set of real numbers, we use that R kind of with a double bar. Generally, I write it with the up and down is a double R like this. Kind of looks like this the way I write it, is like that. That would be the set of real numbers when I write it on the board. Okay, and that would be minus infinity to plus infinity. We don't put brackets on the infinities, okay, because they're technically not numbers. And this would be the whole number line. So we'd actually put an arrow here on the end of that, okay, and there too. So if we were to graph the set 1, 3 using interval notation, we would start at 1 and go to 3 and keep those both open. If we're going to graph the set 2, 7 with brackets, we'd include the 2 and include the 7, okay, in our graph. Okay. And then here's a mixed interval where we're including the 2 but not the 3. So we go from 2 to 3 when we fill in the 2. Okay. Now this actually what we're doing here is taking the intersection. So let me rewrite that. Okay, so this is actually just that third set is this. It's 1, 3, intersect, 2, 7 closed. Okay, so that's what this set is here. Okay, that third set is 1, 3, intersect with 2, 7. And you can see where they overlap. You can see the overlap is between 2 and 3. Okay, and it's going to include the 2, and it's not going to include the 3. So we look at, when we're taking the intersection, we would look at the overlap there, okay, and just see that would be an intersection. If we're talking about the union, we would actually go from 1 to 7 because we'd throw these together, and we wouldn't have a gap in between because we're seeing it can be in either set, right, for union. So the union would be from 1 to 7, 1 open, 7 closed. So here's that 1, 3, now that should be a U there, or 2, 7. See, we're not taking the intersection, we're going to just throw them all together. And we start with 1, we go to 7. There's not going to be a gap there. We just have everything where we have items in either set. Okay, so that's the union of the two. So this is or, the intersection would be and. Okay, absolute value is, by definition, the distance from 0 on the number line. Okay, distance from 0 on the number line. So that's what we mean by absolute value. So remember that idea is that we talk about where we are away from 0. If we're to the left, we count that distance as positive. Okay, so we always include distance as being positive. Okay, so if we're going this way from 0, we count that as 3. If we go from this way from 0, we count that as 5. We never say distance is negative. Okay, so when we talk about absolute value, we're going to use these bars. Okay, and we're going to say that's how far away is A from 0. That's what that means. Okay, so what we're going to do is if we have a negative 3 and we take the absolute value, we're going to be 3 away from 0. So that's going to become a positive 3. So yes, you can remember absolute value is changing the negative to positive, but always keep in mind that it's representing a distance from 0. Okay, so the absolute value of A is A if A is positive or 0. You know, absolute value of 5 is 5. But it's the opposite of A if A is negative. You know, so if A is minus 3, the absolute value of minus 3 is the opposite of minus 3, which would be plus 3. So that's why we say minus A if A is less than 0. We're going to change the sign there. Here's some properties of absolute value. The absolute value of A is always greater or equal to 0 because this distance is always positive or 0. Okay. Now, when it would be equal to 0 is when your A is on 0. Okay. The absolute value of A is always equal to the absolute value of minus A. If we're at 5, we're the same distance away from 0 as if we were at negative 5. Okay. And these are a couple other properties. If you're multiplying inside an absolute value, you can break it out. So absolute value of A times B is absolute value of A times absolute value of B. Okay. So minus 2 times 5 absolute value of B, absolute value minus 2 times absolute value of 5, which is 2 times 5, which is 10. Okay. And same with dividing. Absolute value of A divided by B is absolute value of A divided by absolute value of B, or in this case, absolute value of 12 divided by minus 3 is the same as absolute value of 12 divided by absolute value minus 3, which is 12 over 3, which is 4. Okay, in both cases you have 4 here. Here's where we have to be careful. When you're adding or subtracting, you cannot break out the absolute value. So the absolute value of A plus B is not equal to the absolute value of A plus the absolute value of B. Okay, we have to do this first before we take the absolute value. Think of this as like parentheses. So we could technically say this. Really, you're putting parentheses around the A plus B. Sorry there. Okay, and you're putting parentheses around the A minus B, which means, remember your order of operations, parentheses says do me first, so we have to do the A plus B before we take the absolute value, and we have to do the A minus B before we take the absolute value. Okay, so we cannot break these out. So be careful with adding, subtracting. We cannot break those out of the absolute value like that. Okay, very important that we remember that rule. Okay, and this is a very important thing. The distance between 2 points is the absolute value of their difference. Okay. So if we take the difference between 2 points and take the absolute value, we get the distance between those two. Okay. So the distance, this little d means distance between A and B, is just the absolute value of B minus A. Now it doesn't matter if we do B minus A or A minus B, and that's because if you switch them, you just get the opposite sign, and we take the absolute value, it doesn't matter, right? You'll always get a positive or a 0. Okay. So we want distance between 2 points, A and B on the number line. We just take the absolute value of their difference. We subtract and take the absolute value. Okay. Now keep in mind that that is not equal to absolute value of B minus absolute value of A. So keep in mind that we can't break those out. It's got to be B minus A, take the absolute value. Okay. Not this. Okay, so let's say we want to take the distance between these two numbers, minus 8 and plus 2. Okay, so we're just going to subtract. So A is A minus 8 and B is plus 2, so we'll take minus 8 minus 2 and take the absolute value. So that's minus 8 minus 2 is minus 10. Take the absolute value, get a plus 10. So that's going to be the distance between these two numbers. Now that might be obvious to you, but you know it's important that we are able to do this because sometimes we don't know. Let's say we have a variable and we don't know where in the number line it is. Okay, so we can see the distance between minus 8 and plus 2 is 10. Okay, now notice if I did this, absolute value of minus 8 minus absolute value of 2, right? I'm not going to get, this is going to be 8 minus 2, which is 6. So this would be the wrong way to do that, right? Is to say absolute value minus 8 minus absolute value 2. See, we don't get that distance when we do that. So be careful. It's got to be the difference and then take the absolute value, not the opposite way. Okay? So be careful. We try to avoid that error. Okay, so that's it for section 1.1, part B. We will look over some examples in class and do problems in class, so make sure that you're ready to, to go over that and do some problems regarding this in class.